equipment grounding conductor does not need to be insulated unless it comes into contact with live conductors. In the scenario presented, the ground wire is connected only to the grounded enclosures of equipment. It does not need to be rated for 5 kilovolts. National Electrical Code Article 250.118 addresses the requirements for equipment grounding conductors. It states that equipment grounding conductors shall be insulated or covered where exposed to physical damage or where in contact with any live part. Since the ground wire in question is not in contact with any live parts, it does not need to be insulated. The NEC specifically allows bare ground wires in certain applications, such as in underground runs and in metal raceways. NEC Article 250.119 provides further detail, stating that bare copper or aluminum equipment grounding conductors shall be permitted where installed in a raceway, embedded in concrete, or concealed in walls, floors, or ceilings. Therefore, using a bare number 6 ground wire for a 205 kV feeder does not violate the NEC, given it adheres to the conditions outlined in Article 250.119. To elaborate on the requirements for equipment grounding conductors, it is important to understand their function and how they contribute to electrical safety. The primary purpose of an equipment grounding conductor, often referred to as an equipment ground, is to provide a low impedance path for fault current to return to the source. This path facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses, effectively clearing the fault and minimizing the risk of electrical shock or fire. When a fault occurs, such as a live conductor coming into contact with a grounded metal enclosure, a fault current flows through the equipment grounding conductor back to the source. The low impedance of the grounding conductor ensures that a large enough current flows to quickly trip the circuit breaker or blow the fuse, disconnecting the circuit and preventing the enclosure from becoming energized at a hazardous voltage. Insulating the equipment grounding conductor is generally not required because the conductor is intended to be at ground potential under normal operating conditions. Its primary role is to provide a safe path for fault current, and insulation is not necessary for this function unless the conductor is exposed to physical damage or comes into contact with live parts. However, there are specific situations where insulation or covering is required for equipment grounding conductors to provide additional protection. For instance, if the grounding conductor is installed in a location where it is susceptible to physical damage, such as being exposed to mechanical stress or abrasion, insulation or a protective covering may be necessary to prevent damage to the conductor that could compromise its effectiveness. Similarly, if the grounding conductor is installed in an environment where it could come into contact with live parts, insulation is required to prevent the grounding conductor from becoming energized and creating a shock hazard. The NEC provides detailed guidance on the selection and installation of equipment grounding conductors to ensure that they are properly sized and protected for the specific application. The size of the grounding conductor must be adequate to safely carry the available fault current without overheating or causing excessive voltage drop. The installation method must also be appropriate for the environment to prevent damage to the conductor and ensure its long-term reliability. In the context of a 5 kV feeder, the equipment grounding conductor plays a critical role in protecting equipment and personnel from electrical hazards. While the conductor itself does not need to be rated for 5 kV, it must be sized and installed to safely handle the available fault current. This typically involves using a copper or aluminum conductor of sufficient size to provide a low impedance path for fault current. The NEC provides specific tables and calculations for determining the appropriate size of the equipment grounding conductor based on the size of the overcurrent protective device protecting the feeder. In addition to sizing the grounding conductor appropriately, it is also important to ensure that it is properly connected to the equipment enclosures and to the grounding electrode system. The connections must be made using approved connectors and methods to ensure a reliable and low impedance path for fault current. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods or ground plates, that are connected to the grounding conductor system. The grounding electrode system provides a connection to earth, which helps to stabilize the voltage of the electrical system and provide a path for fault current to dissipate. The NEC provides detailed requirements for the installation of grounding electrode systems, including the types of electrodes that are permitted, the minimum size and depth of the electrodes, and the methods for connecting the electrodes to the grounding conductor system. By following these requirements, it is possible to ensure that the electrical system is properly grounded and protected from electrical hazards. In summary, the NEC allows the use of bare equipment grounding conductors in certain applications, provided that the conductors are installed in accordance with the code requirement. The decision to use a bare or insulated grounding conductor depends on the specific application and the environmental conditions. However, it is important to remember that the primary goal of the equipment grounding system is to provide a safe and reliable path for fault current, and the grounding conductor must be sized and installed accordingly.